Hello, everyone. I'm here to talk about my final project for the Data Center Scale Computing class, and the topic that I've chosen is a one-size-fits-all MLOps engine. The reason why I chose this project was primarily because currently in the industry, a lot of developments are happening towards the area of generative AI, etc. And people are more and more using notebooks as a service rather than using traditional software development practices. So a one-size-fits-all MLOps solution would enable layman to run machine learning models and at scale. The main goal is to ensure we are able to leverage the components that is given by the Google Cloud platform. Some of these components would be Dockers, VMs, APIs, in order to build a prod level system. The list of components in detail that I'm using as part of the project are I use Fast API in order to have API endpoints for triggering the underlying processes. I leverage a Google PubSub um, to have a messaging queue in place. A Cloud Run is something that I'm using in order to have a serverless container in place for me to run processes, followed by Streamlit, where I'm leveraging a UI for users to provide their inputs on, which eventually becomes an input from the machine learning models. Then I am using virtual machines, a couple of them, followed by Dockers. The Dockers are being deployed using Cloud Build. The codes are hosted on GitHub, and the way it works is Cloud Build automatically understands if there's any change happening in my GitHub repository, and it redeploys as and when a change happens. So these are some of the components that I have leveraged as part of the process. Coming to the architecture standpoint, all the user does is interact with the Streamlit UI, and that's it. That's going to be all the user needs to do as part of the machine learning process. What happens right now is once the user fills in the input on Streamlit, it gets converted into a JSON format and it's published into a Google PubSub topic. So a Google PubSub topic consists of a publisher and a subscriber. So once it's published to a particular topic, the subscriber listens to that particular topic and checks whether any requests have come. If there are any requests that have come, it triggers and it acknowledges that particular request and triggers an underlying API, which is a fast API, which would you know which would eventually start the model run, which is the main crux of the entire process. This fast API consists of messages that tell you whether a particular request is successful or not. So once this API triggers the underlying endpoint, which is the machine learning pipeline, it is going to be triggering the machine learning process on Cloud Run. The reason why Cloud Run is being used is for its scalability and for its serverless capabilities. So I don't need to worry about, if there's a bottleneck in terms of number of resources that are coming in, how my system is going to adapt to it. Based on some of the input parameters, I can control the number of requests that are coming in, number of the load balancing process essentially can be controlled on Cloud Run, which is primarily the reason why I'm leveraging that. So once I am done with Cloud Run, the process is executed. I can either store the results on GCS or BigQuery, but for the purpose of this particular project, I'm also giving the facility for my user to download the results directly from the web. As far as the testing and debugging part goes, uh, since we are using the Google Cloud platform, the debugging part of it is very simple since GCP provides the capabilities of logging and provides like in-depth logs for every single process. So API responses I'm getting from Fast API, I would show them in the demo how it looks like. Docker build, the deployment status is seen as and when I'm using Cloud Build on GCP, it tells me whether it's successful or not, along with any issues that occur. Streamlit UI, the main thing that I was focusing on was to ensure there was no package mismatch or path mismatches. This is very critical in order to have all the paths configured properly. Finally, the model pipeline executes on Cloud Run, like I mentioned, and it provides a really, really good logging mechanism, which is easy for us to debug in case any error occurs. As far as the future work is concerned, before I move on to the demo, the future work is to extend the project to leverage higher end VMs to improve the performance of the system. And since we are using Dockers and containers, the whole concept of CI/CD is set up very nicely, and it's easy to add more capabilities and functionalities to the backend if we choose to, take this project to higher levels or the next steps. So quickly moving on to the demo part of it. Great. So, so this first is a VM that is present over here. I have two VMs. One is the subscriber, one is the front end. If you see over here, uh, the subscriber listens to that particular publisher subscriber topic, and the front end is obviously hosted here. Um, this is a build history. I have three Dockers. I have a Docker for the UI, Docker for the subscriber, Docker for the machine learning process. So if any code changes on GitHub for me, these codes are going to automatically redeploy, and I'll know the status of it in case something goes wrong, right? So then I have a subscriber over here which tells me, okay, fine, this is a particular topic. Every time I want to be publishing something over here, I would see the message pop up over here. Like if I pull it, you might see some messages once I've submitted a particular request. And this is the fast API. So the fast API verifies the inputs that come in and it encodes into a JSON format and it tells I need these many variables in my input. If something is missing, it's not going to be passing it. It's going to give me a 404 error. Now, the way things work right now on Streamlit is that once I give an input, I just have a pre-filled input over here. So once I've given the set of inputs for my user, choosing the algorithm, etc., I can just choose to go ahead and you know submit it, and it would automatically run the underlying code. These codes are present on GitHub, and this is triggered by the fast API that is present. Once I click on the submit button, once I click on the submit button, it publishes the message into the publisher subscriber topic. It is pulled automatically over here, and using the codes that are present here and the API, it hits this underlying API for the machine learning code, and it triggers a machine learning pipeline, which gives the user the corresponding results. So as part of this capability, apart from it being stored on GCS, I've also ensured that user is able to download directly from the UI to their systems. So this is how I went about this current project. I hope you guys enjoyed it. Thank you so much.